In the last video on elasticities, we talked about the price elasticity of supply. Now, in this case, the question that we ask is how the supply of a good changes if its price rises by 1%. And mathematically, we now distinguish ourselves from the demand elasticity by including a superscript S in the expression of the elasticity. So here we have the price elasticity of supply, epsilon SP, which is then the percentage change in the quantity supplied divided by the percentage change in the price. So that's again the discrete case, and the continuous case is again with partial derivatives. Now, usually the elasticity of supply with respect to the price is positive. So if the price rises, firms can charge more for their goods and therefore they would supply more. Now I again illustrate different elasticities here in the diagram where we have the price on the vertical axis and the quantity supplied on the horizontal axis. If the price elasticity of supply is equal to 0, then we would have a vertical supply curve. So here it doesn't matter how high the price is, supply would always be the same. One example of this may be the production factor land in a city. So that's basically of fixed supply, so you cannot increase the number of square kilometers of the area of the city basically, and therefore adjustment mainly runs through the price. So if many people want to live there, this would bid up the price, so the price would increase and then deter those who cannot afford to pay that much, but it would not increase supply of additional land. Then we have the case of perfectly elastic supply. In this case, the supply curve would be horizontal. In this situation, it would be the case that if the price falls below the price here, then the firms would not want to supply anything of this good. And if the price increases above this threshold, they would fully supply the good. Now, of course, there are many cases in between. So I've drawn here two different supply curves, S1 and S2, and we now look at their elasticities with respect to the price. So we could have an initial demand curve D here that intersects with both of these curves, and then suppose that demand increases. So it shifts outside. You have a new demand curve D prime that intersects now with the first supply curve and with the second supply curve at different points than initially. Now, however, what we see here is that in this case of the supply curve 1, the price changed a lot while the quantity did not change that much. So in this case, for S1, the price elasticity of supply would be smaller than 1. So this supply curve would be rather inelastic. By contrast, with the supply curve number 2, here the price changes only a little, but the quantity changes quite a lot in percentage terms, and that means that this supply curve is more elastic. So the price elasticity of supply in this case would be above 1. Now, in between, we again have the case of a unit elastic supply curve. And interestingly, all linear supply curves that come from the origin have a unit elasticity. To see this, we will first again reformulate the elasticities as we've done before with the demand elasticities, so that the price elasticity of supply is now given as the price divided by the quantity supplied multiplied by the change in quantity supplied divided by the change in price. If we have the discrete case, and if you have the continuous case, it's again the price over the quantity supplied times the derivative of the quantity supplied with respect to the price, or the derivative of the logarithm of the quantity with respect to the logarithm of the price. Then we take a linear supply curve without intercept, so it comes from the origin, which would be the curve that we have here, where the price and supply are positively related. So you have prices equal to the parameter P times the quantity supplied. So then we can derive the quantity supplied as a function of the price divided by P. So P is how much the quantity supplied reacts to the price. Now, if we use from the previous slide the expression for the price elasticity of supply here, then we get that this is the price over the quantity supplied times the derivative of the quantity supplied with respect to the price. Now, if we look at this here, that means that this expression is equal to 1 over B. And from here, we also see that QS itself is P over B. And then we can just cancel out terms. We will get to B times 1 over B, and that would be equal to 1. So the price elasticity of supply would be equal to 1 for a curve that has no intercept here. Intuitively, and this is what we will see on the next slide, it is the case that for a linear demand curve that is comparatively steep, it would be the case that the price is comparatively high as compared to the quantity at a certain point in time, and that means that a given percentage change in the price leads to a large absolute change in the price. By contrast, if the curve is rather flat, but also comes from the origin, then at a given point the percentage change in the price leads to a rather small change, absolute change in the price, and a comparatively larger change in the quantity. And these effects compensate such that the price elasticity of supply in both cases would be equal to 1. So we see this here now in the graph with two different supply curves, S3A and S3B, because we used S1 and S2 in previous diagrams. And both of them have a price elasticity of supply that is equal to 1. So if we start, for example, at this point, we have a percentage change in the price, and this is comparatively high in absolute terms because the price itself is rather high, and leads to a certain percentage change in the quantity here, so that the ratio of the two is equal to 1. By contrast, if we are at this point, the percentage change in the price would lead to a lower absolute price change, but to a higher absolute change in the quantity. But if we compute the quantity change in percentage terms, then it is actually again the case that both of these results compensate each other out such that the price elasticity of supply would also in this case be equal to 1. So it always depends on not only the slope that we have here, but also on the initial levels. And for all linear supply curves that start at the origin, if we calculate the price elasticity of supply, then these relative changes turn out in a way that the ratio of these relative changes is equal to 1, and we have a unit elastic supply curve. So what have we learned in this chapter? So the price elasticity of supply measures the percentage change in supply in response to a 1% increase in the price. Again, there is a connection with the shape of the supply curve, but the slope is again not equal to the elasticity, which we have seen. So it depends also where the curve originates. And we've seen that all linear supply curves that start at the origin have a unit elasticity. Then we have also seen that there are the polar cases, so we can have price elasticity of supply that is equal to 0. So then we would have that something is a fixed supply and it doesn't matter how much the price changes, we cannot change supply as such. And we can have the situation of a price elasticity of supply that is equal to infinity. So in this case, firms would not sell anything if the price drops below, slightly below this level where they would supply all of their production. The price elasticity of supply is positive, and and the linear supply curves, as I already said, that start at the origin, they are unit elastic. Thank you very much for watching the video, and I hope you found it interesting and useful. For more videos on economic content, please visit my channel that you find here to the left. And to the right, you see the next video in the series at the top, and at the bottom, you see the whole lecture in the form of a playlist.